Let us now welcome Mr. Saket Shendre. Mr. Saket Shendre, a biotechnological expert and technical expert at Organica Biotech specializing in wastewater treatment innovations. Saket holds a bachelor's degree in biotechnology from the University of Mumbai. Saket continued his academic journey earning a master's in biotechnology from the Vellore Institute of Technology. Currently, as a technical expert at Organica Biotech, Saket contributes his expertise to the wastewater treatment division. Saket Chendre's academic prowess and leadership role showcase his multidimensional approach. Mr. Shendre will talk on technological trends in water treatment. So let's welcome Mr. Shendre.
I will be talking about technological trends in the wastewater treatment. I hail from a company called as Organica Biotech, and we specialize in bioremediation and wastewater treatment, among other things. The topic given to us is innovations in wastewater treatment for future-ready construction and infrastructure, which is what we will be focusing on. Our expertise essentially lies in multiple fields, not limited only to wastewater treatment, but also hygiene solutions, aquaculture, agriculture, solid waste management, and sanitation, etc. We also take up full-fledged projects wherein we treat the bioremediation solutions for multiple your government agencies or natural bodies, etc. So, coming to your technological trends in wastewater treatment. So, this is just a market survey, according to which I would like to give a brief gist of where we stand right now in the wastewater treatment space. If you see, the market capital is actually very high. This is just to give us an idea of where in the entire potential of this lies. And if you can see on the pie chart on the right side, that membrane separation and biological treatment are the more predominant kind of investments. Membrane separation again is a process wherein you might require higher investment. So the definitely the amount of capital wise it would be higher, but biological is a more frequently introduced system. That being said, systems need to go hand in hand, and that is when you can achieve true proper water quality. Again, it cannot be just one type of system that will help you achieve all sort of results. That has to be a case to case basis essentially. The major market capital is focused on processes like I mentioned, membrane separation, biological treatment, and biological treatment in itself has been around for the past few decades, but right now it is being used as the choice of treatment for your methodology or your treatment methodology for your wastewater treatment. That being the reason because it has a huge potential and it is constantly evolving. Isolating these microbial solutions and implementing them is a continuously evolving process, and ideally this is something that can go on until the field evolves, and it will evolve along with the field. So disinfection again is something that is very routinely used. UV, RO, your membrane separation is also something that is routinely used for as a process. You can see somewhere around 10% of the market cap lies in your disinfection, 30% is around biological. The disinfection again will be utilized. Apart from that, there is sludge treatment, which is a very predominant issue, and it requires you stabilization before disposal. Sludge treatment also is very relevant, specifically in cases like these where construction is very in the focus. What would happen is you would require this many a times, again, depending on the legality of it, depending on the governing authorities, when and where it can be implemented. Sludge treatment can give you good stabilized sludge, which is a solid inert material which can be utilized for construction purposes, and it has been in some of the areas. Again, that depends on the area wise allocation, the governing authorities, etc. So like I mentioned, a case to case basis for each. So coming to your biological treatment consisting of bio augmentation, it is the introduction of beneficial organisms into your system. So, like I mentioned, this has been around for a while, but bio augmentation truly cannot be successful until you understand what is the sort of effluent that you are dealing with. What kind of water needs to be treated will lead to what kind of solution has to be given in the first place. So bioaugmentation essentially is introducing these organisms which are naturally present to a different space where they can do their magic and essentially give you the purification in your systems. The bioremediation is utilization of these microbes to bring about degradation, that is using inducible degradative bioenzymes. Essentially, microbes are storehouses of enzymes, and these can utilize the organic pollutants, that is your carbon, nitrogen, phosphorus, essentially, among other things, along with some, say, your iron, sulfur, etc. To degrade them, they can utilize it as food and then provide, they sustain their own growth as well as they provide your reduction in your water parameters. So that is the basic ideology here. Again, it's a very basic principle, very predominant technology, but right now it is more in focus and it will be in focus because it is a proven methodology as of now. Biological means for wastewater treatment, just some of the things that I mentioned, it is comparatively inexpensive as compared to maybe running an entire Fenton process, or maybe even considering, doing membrane separations or ultrafiltration, etc. Again, like I mentioned, these technologies need to go hand in hand. So the optimization of each is what needs to be in focus. The proven methodology for treatment, like I mentioned, has been around for a few decades, and right now it is the peak choice of treatment for any sort of wastewater apparatus. It tackles complex effluents. We have dealt with effluents wherein the COD has even gone up to 1 lakh plus, and so just giving the gist here that biological treatment has that potential to get to that level that it can provide your reduction values even in toxic environments, which is contrary to the popular belief, but what happens is you need to have the right kind of exposure to the microorganisms. You need to have the right kind of research to be backing your treatment, essentially, which again this company has specialized in. Organica Biotech has been here for around 25 plus years, and we specialize in these treatments since the beginning. So again, wide range of action. Like I mentioned, the enzymatic pathways that can be followed are multiple, and pretty much anything organic can be doable, and also some sort of inorganic materials. Again, it's a sustainable sort of solution where you're not introducing chemicals which will create more intermediates, which is going to cause downstream process problems. So this is sort of like a one-stop solution where you can be rest assured that okay, I can use this treatment and not compensate my downstream treatments or upstream treatments for that matter. So just a basic gist of biological treatments. You have your anaerobic sort of treatment and your aerobic treatments. Aerobic treatments are more predominant, especially in India, where activated sludge processes is wherein you have an activated microbial sludge, which is recirculated through the system, which gives you your reduction. You have your MBBR type of system, which is a moving bed bioreactor type of system, which has an attached growth for your microbial treatment, and it essentially increases the surface area and gives a higher reduction with a lesser area. Your SBR is a very commonly used methodology wherein, especially in government sectors, wherein you have huge MLDs of water coming in and they need to be treated in batches. So it's a sequential batch reactor. You have membrane bioreactors, which is a comparatively newer concept. Again, like I mentioned, these biological treatments need to go hand in hand with the engineering of it. The aerobic treatment, again, like I mentioned, is a USB or an upflow anaerobic sludge blanket, which is more commonly seen. You also have other sorts of treatment like expanded granular sludge blankets, etc., wherein you have to be more attentive towards the kind of treatment or the more type of attention that you give so that your system runs smoothly. So again, the efficiency of both is really great, really commendable. 90%, 95% efficiency can be achieved. That again depends, like I mentioned, all the systems need to be going hand in hand for that. So, what are the key issues faced in the construction industry? Firstly, the parameters of available water need to be suitable for usage. Just as an example, for example, if you were to utilize water, maybe say you dug a borewell or whatever, and you were to utilize this water for concretization. Now, concretization has particular standards. Maybe you have your IS 456 2000. So, according to IS 456 2000, you might need an organic content lesser than 200 ppm. So achieving that is going to be difficult unless you utilize these technologies, wherein the key focus is to degrade this with utmost efficiency. The other one is space availability, specifically in areas like metropolitan cities, Mumbai, Pune, wherein right now, even to get an NOC for a building or a commercial space, whatever it might be, you need an STP sort of setup at least, or maybe an OWC. So the space availability is another issue that needs to be tackled. Power consumption and a fixed space allocation. If I were to say build 10 tanks here, maybe if I were to do something on the same space, I would not be able to shift it back to another space. So that is something that needs to be keeping in consideration when we are going for a construction project. The feasibility of the same is again a questionable aspect, depending on the type of process that we utilize. We would have to optimize the process and see where it takes us. So how do we tackle these issues? Like I mentioned, biological treatment is a great solution for it. Apart from that, we have a solution which is a packaged wastewater treatment units, which has been very useful, especially like I mentioned in metropolitan areas where you have a low footprint. It comes as a fully packaged and modular unit. You have a low operating and investment cost, and there is automation so that you can have your electricity, etc., to be controlled periodically. To be specific, there are also technologies that can be utilized, including your ECO processes. You have, like I mentioned, chemical reactions or DM water plants can be set up wherein you want a TDS level of a particular value. For example, your TSS needs to be somewhere around 600 according to concretization standards. So you would require suitable filters, you would require suitable membrane osmosis plants so that you can utilize this water for your specific purpose. Again, like I mentioned, each system has to be thought out well, designed accordingly to your requirement, and depending on the requirement, it can vary on the purpose for utilization and what is coming in. So your process will be designed on the basis of what comes in and what needs to be going out. That is where again we have a specialization in one of our clients, Revive Realty, again a construction space. They provide commercial spaces to buildings where like I mentioned, sewage treatment is a huge issue, specifically because you want to reuse this water. You do not want water to buy more water. Essentially, buying more water is buying into your profits, it's buying into your costs. So you don't want to increase the costs, you want to reuse the water, utilize what is already there. Now there are issues with sewage treatment plants, including odor control. There is improvement that needs to be done in the treatment efficiency, and this can be achieved using bioremediation and sewage treatment methodologies going hand in hand. So this is just one of our success stories to share with you, wherein we were able to control odor control, and then there was also some turbidity in the water parameters, which could be easily controlled using microbial solutions, again depending on the organic content.
Thank you, Mr. Shendre, for your insights on technological trends in water treatment.